Good afternoon, everybody. This is a review of what we have done over the last couple weeks in our stats class, or what will soon be called applied research class. This review will cover the experimental, the classic experiment, quasi-experimental methods, as well as the sampling, more in depth on sampling with some good exercises. First, let's start by just reviewing quantitative versus qualitative. Quantitative, remember, it's numerical data, so it's going to be working with your higher level variables with ratio and interval levels that are numbers. And qualitative begins with assumptions, data collection, and then in the natural setting. In other words, it's talking to people up close, and it's a more personal one-on-one interview. It's collecting data that you're observing while you're in the field. You could possibly be just in the field watching, as we talked about, but it's more in the natural setting, and it's more personal and involves more in depth on your actual elements that you're studying, and it can be both inductive and deductive. Now we're going to go over just a couple examples. We're going to look at both quantitative and qualitative hypotheses and questions. First, how many times does a juvenile offender commit a crime before arrest? That should tell you right there this is a quantitative, so we're looking for numbers. Hypotheses could be anything from a juvenile is more likely to commit over 10 offenses prior to arrest, or before a juvenile is arrested, they're more likely to have committed 10 prior crimes, anything like that. And in order to collect this data, how do you think? Think for a second. How would you collect this data? If you needed to know how many times they've actually committed a crime, well, let's see. It may not be documented if they have. So we might have to do a survey of asking juveniles that have been arrested how many times they've been offended. So the best way to do it would be a survey, collect the data, and evaluate your hypotheses. The next question is, how does a juvenile feel after returning home from detention? This is qualitative. You're asking a more personal question, juvenile feel. That's not a number. So that's going to be your in-depth qualitative study. So to make a hypothesis on that would be, and this can be anything that you are focusing on. So a juvenile is more likely to feel depression following detention. A juvenile is more likely to suffer post-traumatic stress disorder after detention. A juvenile is more likely to be susceptible to suicide attempts after returning from detention. So it's whatever you're wanting to focus on. And I want you to think about these as you go through and try to come up with your own hypotheses while we do ours together. And just a review of causation. We talked about this more in research, but this does impact what we're doing now. So let's just review these. Empirical association, or causal validity, is evidence that there's an association between the independent and the dependent variable. Remember how we talked about types of error, and that what we're looking for in any quantitative study is there an association between our variables, whatever it is it positive or negative? Appropriate time order is a variation, and the independent came before the dependent. In other words, we need to make sure that any change in the independent didn't happen after its relationship with the dependent, because that means we are not in the correct order to look towards valid causation and causal validity. Non-spuriousness means the relationship between the independent and dependent is not caused by a third variable. So if it's non-spurious, which is what we want, it means that it's more likely that the relationship that we encounter as our result is from our result or outcome that we encounter after our testing is from a relationship between the independent and dependent variable. Mechanism is just a term that you need to notice. It's a confidence that there is a causal connection between the independent and dependent variables. So if mechanism is present, then we can be confident that there is a relationship. Again, just a quick review. Levels of measurement we talked about. Nominal, ordinal, interval, and ratio. Nominal, there's no order, no sense to the label. You know, what's your favorite color? What's the color of your eyes? What's gender? Ordinal is in an order of some kind, but the orders don't really mean anything. So like a lot, like, dislike a lot. If you ever seen the surveys where you may see that the answers are 1 through 5, but they don't mean anything. There's nothing, they are just labels for words, for categorical. The difference is uneven, like your level of education. So you can't, there's no clear measurement between freshman and sophomore. Interval, same interpretations like temperature. It means there's no true zero. For instance, height and weight, because even though, yeah, there's no zero in height, it's always going to be over zero. And the distances between the attributes, like your temperature, 31, 32, they are equal. So, in the same thing with your weight, from 5 pounds to 10 pounds there's a pound in between each of the attributes. Ratio, where we talked about the true zero, where sentencing outcome, sentencing length at arrest, how many friends you have, how many prior convictions you've committed. Quickly to review again for validity versus reliability. Validity refers to the ability of a measure to accurately measure the concept it claims to measure. Example, that you are measuring, if you're measuring height, then you wouldn't see how much they weigh. So you want to make sure that whatever you're using in your testing, that you're accurately testing it. We did go over this. Reliability refers to the ability of a measure to consistently measure. So that means if you're measuring weight, that you want your scale to come up with the same weight every single time before any change occurs. Reliability, as we talked about, there's the test-retest method, inter-rater reliability, concurrent reliability, and the split half reliability. So I'm not going to go back over these. You can pause them and review if you want to, but we've already talked about these. I brought this up so that we can get to our next, which when we talked about reliability, we're talking about testing consistency in a study. So the reliability coefficient that we've talked about in class, meaning the R value, the R squared value, it's testing the data and not the measurement tool. That's what we need to be sure that our reliability coefficient. An example, a test to college students, and then you give them the same, and if you gave that same test to third graders, that measurement tool is not accurate. So what we're going to see when we look at, when you look at research and when you read articles, you'll see R values, you'll see alpha values, and the alpha values are often represented by the little squiggly upside down circle. As I have already gone over, you'll see that number between 0 and 1, which is your reliability coefficient. So if it results in 87, that's a pretty high on the scale that your measurement tool is measuring what it should be. Okay, with the validity coefficient, it's very similar to the reliability score. It too is measured with R from 0 to 1. And the higher the R value, the higher the validity. So if we get something like we looked at before, and remember what I talked about, it always depends on the level that you report. And normally 10 to 20 is low, or anything under 20 is low. 20 to 50 is medium, and then anything over 50 is considered high. And remember that you can have reliability without validity, but not validity without reliability, because you can get the same results over and over again, but that doesn't mean that the results are actually accurate or measuring what they're supposed to be measuring. Reviewing an experiment. Experiment is a process of observation to be carried out in a situation expressly brought about for that purpose. I'm reviewing this, and if you want to skip past this because you understand it, I'm just including this in the review so that there's not any questions over what we're going over. It's specially suited for hypothesis testing. So when you have your research question and you have your hypothesis, using the true experiment is especially helpful. These experiments often occur in the field, right? Normally you might go out to a facility and separate the offenders into two different groups. The classical experiment, which is what we've been throwing out for the last couple weeks, you have your independent and dependent variables. You have to have those in your experiment, in any experiment. You have pre-testing and post-testing sometimes. It just depends on what you're testing. In criminal justice, if you're testing a program outcome, you would have this, because you might test all of your participants before either group goes into a program. You have your experimental and your control groups. Your experimental group is the group which you're going to give the testing, or you give them the program. They have it. You may have two groups. They're the ones that go to the group. They're the ones that you're going to give the program to. They're the ones that are going to take the medicine. Okay, and the control group is obviously the one that does not, the one that you are comparing to the experimental, like your criterion. Remember when we talked about criterion, where if you measure something against something at the very beginning, that's your criterion level. Many times, well, in an experiment, the independent variable takes the form of a dichotomous stimulus that is either present or absent. What this means, and I have not gone over this, this means two. So that means that the independent variable may be yes or no, may be recidivate or not, might be male or female, might be incarcerated or not, may be in a community program or not. The independent variable varies in our experimental process. The dependent variable, as we know, is our outcome. It's the effect we expect to see. It's the effect that we're going to measure. Could be physical conditions. It could be their behavior, their attitudes, feelings. These are more qualitative, but it could be the number of crimes they committed. It could be the number of times they committed suicide. It could be the increased number of behavioral incidents. Again, pre-testing and post-testing. I've already gone over this. Subjects are initially measured in terms of the dependent variable prior to association to the independent variable. So then they are exposed to the independent variable. They are remeasured in terms of the dependent variable, which is post-tested. And the differences noted between these measurements are attributed to the influence of the two variables. So it's very, very easily laid out. As we go through these slides and as you have read, you can encounter errors within your research and your data. And what we're trying to do is prevent any errors. And these experts have come up with type 1 and type 2 errors. Type 1 error is if we see a difference, we want to make sure it is due to the independent variable and not to a difference between the two groups. That right there is why it is so important that our samples are as alike as possible. Remember how we talked about that? We want these two groups to be alike because we don't want something that's making them different to cause that difference in the outcome. That would be a type 1 error. So for instance, if we were measuring juveniles with mental illness and we wanted to, one group we had 80% juveniles with a mental illness, and in the other one we had 100%. So our groups are so different that they're not going to come up with the same. And if we, as the control, if we give if we expose those groups to treatment, if we expose one group to treatment and compare it with the other group, how will we really know that it's the treatment that caused that outcome if they were so different to begin with? Placebo, as we said, you don't want people to know they're receiving the treatment. And we talked about a double-blind experiment. It's on your test. Neither the subjects nor the experimenters know. So nobody knows who's got the placebo and who's getting the actual treatment. So now we're going to look at those hypotheses and questions that we had earlier in the slides. So to see if can you use an experimental design to test these hypotheses. So we have how many crimes does a juvenile offender commit prior to their first arrest? Remember we said something, a juvenile is more likely to have committed 10 crimes prior to their first arrest. And the next one, how does the juvenile feel after returning home? Juveniles more likely to feel depression after returning home. First of all, it's very difficult to do an experimental design on either one of these hypotheses, because here, how many crimes did they commit? You would need to do a survey method to survey juveniles following their first arrest. So there's no interceding cause. There's nothing that you're putting in there. You're not separating your two groups and giving them an interceptor, a program. Now, you could use an experimental method if you were testing the two differently. For instance, like if you had two groups and you wanted to see which group after incarceration recidivated more. That would be an experiment. The same as how does a juvenile feel after returning home? This is more of we talked about a qualitative design where you are going to be doing in-depth within the community on-site work. So you're not going to separate them into a control group and a experimental group. And talked about quasi-experimental designs. You use a quasi-experimental design when randomization is not possible. So quasi means to a certain degree. So it means to a certain degree it's an experimental design. It does not have a stringent control of over internal validity threats as the true experiments do. So in this type of experiment, you have two categories, and your groups are not going to be equivalent. So you remember when we talked about earlier about the type 1 error? This is not going to be present in a quasi-experimental design because both of your groups are different. So if you're studying incarcerated and non-incarcerated juveniles, you would have to put them into those groups. So therefore, it's quasi-experimental. This is just another way to say what we said before, experiments and causality. Experimental design ensures that the cause precedes the effect. In other words, you're testing your result and your effect, so that cause comes before that. You have empirical correlation exist via comparing your pre-test and post-test. You do your measurement before the cause and after, and that there's no spurious third variable influencing your correlation. Just a review of what we said earlier. Now there's a few variations that I'm not sure we talked about before on the classical experimental design. The two are called post-test only design, where you do not have a pre-test measure, and yes, this is used when the pre-test might bias your results. There's also the factorial design. This is where you have two experimental groups instead of the one. For instance, you might be looking at levels of incarceration versus non-incarceration. So you might have your experimental groups might be low-level supervision to high-level supervision compared with non-incarcerated. All right, let's look at this one, and I want you to figure out the example of what kind of design would you use. So researchers at the University of Maryland conducted an evaluation of the Baltimore Drug Court. For their research, eligible offenders were randomly assigned to either the drug court or to the treatment as usual. Sorry about that. Were assigned to either the drug court or to the treatment as usual. These are some of your key words: randomly assigned. The results of the group placement were given to the judges as a recommendation. In most cases, the judges who agreed to participate in the study beforehand sentenced offenders in accordance with the randomization. The results showed that participants in the drug court were less likely to recidivate than those in the control group. So you have eligible offenders that were randomly assigned to either the drug court or the treatment as usual. So there was no you did not have to pull them out for any reason. So this is going to be a experimental design using randomization. We talked about cohort designs already. Go into it a little bit more. Cohort would be a group of subjects who enter or leave an institution at the same time. A cohort is any group of subjects that you're using in your experiment, in your evaluation, that are staying together. So you might look at a group of subjects. The most famous is where's my book? Is the birth cohort, where researchers looked at a group of children over an 18-year period from the time they were born, and they went back and just researched everything they did. You can also do it over a longitudinal time of a cohort, where you pick them from the beginning and watch them as they travel through their 18 years, or travel through their treatment, or are released at the same time from an institution, and see how they recidivate. Time series designs examine a series of observations over time. So the observations are compared before and then after some intervention. So you could put just like on the other one, where you have two groups and one goes to drug court and one does not, and then you watch what happens over a period of time. That would be a time series design. Your interrupted time series design okay, I'm not sure if I'm repeating myself. I had a little trouble with my recording. The time series designs is where you would examine your series of observations over time. In other words, you compare before and after some intervention. So perhaps the example we had before about drug court, so possibly maybe you are observing your juveniles, the ones that go to drug court and the ones that don't, and so you're going to observe what happens after they are sentenced and followed. There are a few variations in those types of time series designs where you're looking at it over time. The interrupted time series design, where your comparison group is not equivalent. There's also the case-oriented research, where we talked about this, that many cases are examined so that you understand just a small number of variables. So you might just look at recidivism and sentence length, and that's all you're looking at. Or you might have variable-oriented research, where you have a large number of variables that are studied for just a small number of cases. And an example would be the case study design that's more in-depth. So you're just choosing, like a qualitative design, where you're just choosing a group of offenders, or a small group of people, maybe even female police officers in a small rural area. Now what's going to happen, I'm going to move to I'm going to pull up some more PowerPoint. Okay, don't get nervous, because I'm just giving you some basic information to help you understand the examples that we're going to do, and the ones I want you to do for homework to be turned in on week 5. The definition of sampling error. Remember, we talked a minute ago about a type 1 error. We'll talk about it more. The sampling error arises, and I want you to try to read through this. You can stop this recording and just read it. But it arises because infinite samples can be drawn from any specific population. In other words, if we have a huge population of King University faculty and we want to do a study on the faculty, so we need a sample that accurately represents the population, which is the faculty. So, but we can get, and we want just 100. Well, we're not going to do that. We'll say we want 20, but so we have to be careful on how we get that 20. How can we ensure that it's representative? Because like in a faculty, you've got your faculty that are brand new, some that have never taught before, some that are just starting in. You've got those that have been teaching for 15, 20, 30 years, but maybe are new to that university. So any sample that is drawn by a researcher is only one of a multitude of possible samples, right? Just explain that. So what sampling error is, since it is impossible to actually draw an infinite number of samples from a population, every sample has its own distribution and set of descriptive stats. Remember, every sample that you pull from that population is going to be distributed in a certain way. They're all going to be descriptive. You can have certain males, certain females, different ages. They can be very equal or they can be very different from actually the population. Therefore, sampling error is that error that is introduced into a study by the uncertainty associated with trying to draw an infinite number of samples from the population. So it means any error that you have that results from a sample not representing the population. So you want to reduce that sampling error as much as possible by ensuring that your sample does follow the population. So there are ways when we talk about our means and our standard deviations, we would like the sample that we use to accurately mimic what the population would have under the means and the standard deviations. And the way we do that, we make sure that our sample is accurately portraying the population. We're not going to do that. I'm going to stop the recording now and do a few more regarding bivariate and multivariate analysis, as well as some examples for sampling.